Hi, welcome to Beginning Statistics. I'm going to talk about organizing quantitative data. First thing we need to look at is we have two types of quantitative data, if you recall. We have discrete data here, and we have continuous data. If you remember, discrete has a finite number of values, a countable number of values, whereas continuous has an infinite number of possible values. Okay, so we're going to approach this organizing of data. We're first going to look at discrete, and then we'll look at continuous. If the discrete data has a small number of values, then we can use the same process that we use for qualitative data. Okay, so we can use the same qualitative data organization that we used before. We can use that for discrete data if there's a small quantity of values. The difference is the bars of the chart need to be touching. We call that a histogram. Here's an example of discrete data. It's the number of available cars in a household based on a random sample of 50 households. So you have lowercase n of 50, and here's and these are just discrete. You have either 0, 1, 2, 3, 4, and 5. So you just have 6 different values. So that's a small number of values. So we can use that. We can use the process that we used before, which is we start with laying out what are the values, 0 through 5. Then we tally up how many of each of these values there are. We count that, and we have a frequency, and we total it. We need to make sure we total it equals this. When you add all of these up, that they total up to 50, so you did everything right. Then you can calculate relative frequency by doing our division here. 4 here divided by 50, and that's 0.08. 13 divided by 50 is 0.26. 22 divided by 50 is 0.44. 7 divided by 50, on and on. So we have a relative frequency, and we also need to count those, and these need to equal 1. What we also can do then is we can do our chart the same way. Here's our actual frequency, and here's our values, the number of cars. Notice the bars are touching. So we call this a histogram because we're using quantitative data. We can look at the relative frequency as the y-axis, same x-axis. Note the shape of the graph is the same. So discrete and qualitative, very, very similar if there's a small number of discrete values that you're talking about. So let's move on to continuous data. Let's start with an example. Here's some continuous data. This is the number of seconds between eruptions of Old Faithful geysers. So 728 seconds, 678 seconds. So we call this continuous data because there's a large number between each of these when we're talking about seconds. So you have this big gap. So this isn't discrete because there's not one specific point. There could be anything between 728 and 678. You could have anything, right? We start with building a class. We're going to use the class to create a frequency table and our histogram. Flipping back to discrete data, if you have a large quantity of values, then we're going to use the same process as continuous data. But the point is, we're going to use classes to create these intervals that are going to have a lower class limit, and they're going to have an upper class limit of that interval. These class intervals, there's no overlap, and each class has an equal width. And it sounds a little bit confusing, but let's look at an example. We create the tables and the histograms kind of using the same process we did with discrete and qualitative, but we're going to use the frequency of the class as opposed to just the frequency of a specific number. The first thing we need to do is we need to kind of create these class sizes. And there's a little bit of kind of art to it that you can get into some trial and error, because if you make the classes too big, then you might lose interesting data. If you make it too small, then you have too much data. You really want to have the number of classes somewhere between 5 and 20. The fewer data points, the smaller n is, then you'd probably want to be on the 5 class. If you have n is in the hundreds or so, then maybe 20 or somewhere in between that. So the guidelines for doing the lower class limit, so we choose the smallest observation in the data set, or some sort of convenient number that's just slightly smaller. And we have this example of convenient number here in a second. So to determine the class width, we take the largest value of our sample, and from it we subtract the smallest value. And then we divide that by the number of classes we want. Now, kind of have to pick somewhere between 5 and 20. These numbers, we just look at the max and the min of the data in n, and we do that math. And this is where we kind of get a little bit, have to trial and error with the number of classes. From this, it determines the class width. And then we take that number and we round it up to a kind of a convenient number. Let's look at our example. So we have all this continuous data, and we're going to create a class. So our smallest number in here is 672. 738 right over here is our largest number. The first thing, like I was saying, is we do this math. So we subtract 672 from 738. I'm going to pick 7 classes. Okay, I'm just picking 7 just so that you see how it works, and we'll tweak this in a little bit. So I'm going to pick 7 classes. 7 into this difference here is 9.4. Then I'm going to round up to 10. Nice even number of 10. Okay, so we have smallest 672. We have 7 classes. We have a width of 10. I'm going to start at 670 instead of 672. I'm going to kind of go down because 670 is going to include my 672. And if I do 7 classes, then I will get all of my data points. So if I start at 670 and go to 679, then I'll include my 672 all the way. And I keep doing this on the 10s. I get all the way to 730, all the way to 739, and I'm including my 738. So you see how this guy ends up in here, and this guy ends up in here, and everything else is in between. Also note, there's no overlap. We go from 9 to 80, 89 to 90. No overlap. And all of these are even. The class widths are even. So to create the frequency table, we, instead of writing the specific values, we write our class. And then we go through and count. We tally up. We go to the first one. Is that between 670 and 679? Yes or no? We tally where everything exists. Then we count the tally, and then we divide the tally by the total of 45, and we get our relative frequency. From here on, it's the same thing we've been doing. We just create a class so that we can create the tally frequency and the relative frequency. So the next thing is we can do a graph. And you can see we've graphed this. We've just done our first class, 670. Now I'm not putting 679. I'm just putting the starting point for ease of use. And then we have 2 that are in here. We have 7 that are between 690 and 700. Don't have any between 680 and 690. And these are kind of big. What if we doubled the number of classes? We could go ahead and double. What we're doing is we're just going to cut the classes in half. So 670 to 674, 675 to 679, and then all the way down. We have the same starting point, and we have the same ending point. We've just kind of cut them and done it by 5s. So that we end up with 14 classes. And we tally up the same way we tallied up, and we add up the same way we add up, and we divide by 45, and we have our relative frequency. But what we get is a different chart. So we have the same, the frequency might be smaller, so this y-axis might be a different number because you have smaller classes, you could have fewer in there. But the interesting thing is we still have between 680 and 700, we still don't have anything there. we see that between 670 to 675 there's 1, and 675 to 680 there's 1. We see some evenness here, the same number between here, and we see some variation here. As when we were looking at before, we would see from 700 to 710, and these numbers kind of were the same. So you don't see this type of variation when you have the larger graph. So think of this graph. I'm going to flip really quickly back to our previous graph and see how these were kind of lumped in. These are the same. It looks like there's some consistency here. When you go down to this one, we see, oh, there's some variation here. Okay, that's all, folks.